Hi, now we are in the second questions for subtopic power. Okay, and this question is concerned more on the instantaneous power. Okay, instantaneous power. A car of mass 1,500 kilograms starts from rest and accelerates at 4 meters per second square for 5 seconds. It then moves with a constant velocity of 20 meters per second. The total resistance to motion is 550 Newton. Find the instantaneous power of the car at time 2 seconds and also at time 6 seconds. Right? So information given here is the mass, the mass itself, the mass of the car starts from rest, so that means initial velocity is 0, acceleration for 5 seconds, the constant velocity 20, resistance to motion, so this is more to friction. Find the instantaneous power. So we want to find instantaneous power. Power instantaneous at certain time. So we have 2 time slots here. Okay. So we have 2 seconds and 6 seconds. Now it's better if we draw a graph for these questions to represent the motion. Okay. So we draw a velocity time graph to show what happened. So from it starts from rest, so the velocity start from rest increases to 20. From 0 increase to 20 in 5 second time. So from 0 to 5, okay, from 0 to 5, 0 to 5 second, it has acceleration 4 meter per second square. You see, it has acceleration, it has gradient, it has acceleration. Velocity increases from 0 to 20 meter per second. Okay, and then after that, the velocity is constant. After that, it then moves with constant velocity 20. So it moves with constant velocity 20. Acceleration 0. So the first part, it has gradient, acceleration 4. But the second part, constant velocity, acceleration 0. Right? So we want to find power at 2 seconds. We must identify where is 2 seconds. So at 2 seconds, what's the velocity? We don't know. We have to find out, yeah, using the kinematic equation. So 2 seconds is around here. We don't know the velocity, but at 6 seconds, it's already after the 5 seconds. The 6 seconds is over here. So it has this time the car is already moving at constant velocity. So at 6 seconds, the velocity is 20. Velocity is 20 at 6 seconds. Okay, so it's easier with a graph. Now, to find instantaneous power, we have to draw a free body diagram. Okay, and this is the free body diagram we draw. So at 2 second time, okay, what is the forces that acting on the car? Okay, so this car, it has the force of the motor going forward. We must draw a free body diagram. To find instantaneous power, we must draw free body diagram. I will tell you why later. We must draw a free body diagram, show all the forces acting on the object. Just the x-axis enough. The y-axis, not necessary, because the friction already provide. Unless the friction, it just give you the coefficient, then you have to find a normal force. To find normal force, then you need to draw the y component. So this time, the friction already give you, so no need to draw the y component. Okay, just concentrate on x component. So on x component, we have the force of the motor forward and the friction going behind. And then acceleration forward 4. We must also draw the velocity. Velocity forward, we must draw this. Because why? Because we need to, later we need to find angle theta between velocity and force. Okay? So to find instantaneous power, the formula is power equal to F dot V. Dot product is using cos theta. But since this one is you want to ask about the power of the car, so it's a power of the motor. Power of the motor. And this is the power. This is the power of the motor. So to find power of the motor, we use force of the motor. Force of the motor dot velocity. So instantaneous power is only the power at 2 seconds. Power at that time only. Okay? Because instantaneous power, the power changes according to the velocity. Velocity changes with time when it has acceleration. So different time has different velocity. So different time, different velocity, different power. So instantaneous power is power at certain time. So for part A, it want the power at 2 seconds. Okay? So we need to find the force of the motor and also the velocity at 2 seconds. Okay? So how to find the force of the motor? So we use the Newton second law. Total Fx equal to ma. Because in x component, it has acceleration. So it has resultant force to the right. Force of the motor is bigger than the friction. And now we apply the sign for direction. Follow acceleration positive, opposite acceleration negative. So put a sign there. Put a sign there. Follow acceleration is positive, opposite acceleration is negative. So we can say force motor is positive because follow acceleration. Friction is negative because opposite acceleration. So just write that down. Okay. F motor is positive, negative the friction. Okay. Friction and mass A. Now, force of the motor, we can find the force of the motor. Friction is 550. Mass given is 1,500. Acceleration is 4. Acceleration is 4. So, force of the motor is equal to, we got the force of the motor, 6550 Newton. That's our force motor. So we got the force of the motor. Now we want to find velocity at 2 seconds. So velocity at 2 seconds, we have the initial velocity. Initial velocity is 0. Acceleration 4. The time taken is 2 seconds only. So find the final velocity. Alright. Initial velocity is 0. Time taken is 2 seconds, from 0 to 2 seconds. Acceleration is 4. So what is the final velocity? So just use the formula V equal to U plus AT. Right? V equal to U plus AT. So U is 0. And then 4. And then time is 2. So we have 8 meter per second. For the velocity at 2 seconds, this is velocity at 2 seconds. Okay, so we got the force of the motor and also the velocity. So now just substitute inside. Okay, force of the motor is 6550. Velocity is 8. Cos so angle theta. What is angle theta? What is angle theta? Theta is angle between force and velocity. That's why we need to draw the velocity. So theta is the angle between force and theta is the angle between force and velocity. These two. Yeah. Theta is the angle between F and V. So F and V, they are same direction. If same direction, then they are 0 degree. Okay. And cos 0 is 1. Okay, so what's the answer you get? After multiply, I get 5.24 exponent 4 watt. Yeah, that's the answer. Right, that's the power at 2 seconds. So you see, there's similarity between power and work done for instantaneous power. So if we want to find power, we use the F dot V. If we want to find work done, we use F dot S. So if work done, here we draw displacement. We draw displacement, and the angle theta is the angle between force and displacement. Force and displacement. But if for power, the angle theta is between force and velocity. See, it's the same thing. It's using dot product. Both use dot product, and both use dot product, and both also using cos theta. Okay. So this one use velocity, power use velocity, work done use displacement. Okay, work done use displacement. Now, okay, let's go on to the question part B. What happened for the instantaneous power at 6 seconds? So at 6 seconds, there's no more acceleration. No more acceleration. This is important. At 6 seconds, no acceleration. The acceleration 0. But velocity, we know it is 20. Yeah, velocity is constant because acceleration 0. Velocity is constant at 20. So we also use, oh, sorry. This one should be, so power at 6 seconds. Okay, so we also use F dot V, force of the motor. Force of the motor, power of the car is the force of the motor times velocity. So Fv cos theta, yeah, force of the motor only. Now, velocity we already have. We already have the velocity, which is 20. Yeah. At 6 seconds, the velocity is constant already, 20. But we have to find the force of the motor. So we also use the Newton's law. This time is Newton's first law, because no acceleration, acceleration 0. Acceleration 0 means it is equilibrium. This object is now in equilibrium. Equilibrium means what? No, if no acceleration, 0 acceleration, constant velocity, 0 acceleration, means force to the right equal to force to the left. Okay? If no acceleration, we just put going to the right positive, going to the left negative. Okay, and then we find out the force of the motor. So force of the motor is positive, and then friction is negative. Okay, 0. So you see, force to the right, motor, equal to force to the left, friction. So force of the motor is also 550 Newton. Because it is same as the friction. Okay, no acceleration, no resultant force. Resultant force is 0. No acceleration. Okay, so this is force of the motor. Just substitute inside, and we are good to go. We got the answer. Velocity is 20. So what's the angle between force and velocity? So between force of the motor and the velocity, they are same direction, parallel to each other. So cos 0. Yeah, same thing. Cos 0 degree. And cos 0, we know that it is cos 0 is equal to 1. Okay? And finally, our answer is 1.10 exponent 4 watt. That's our power at 6 seconds. Okay? So our power, you see, power at 2 seconds is 5.24, but power at 6 seconds is 1.10. So This is what it means by instantaneous power. The power depends on velocity and also the force at that time. Different time has different force motor and different velocity. So resulting in different power at different instant. Right? So okay. So that's all about power. So thank you for joining the videos and hope to see you again in the next upcoming videos. Thank you. Bye.